All right, so for number 9, let f be the function defined above. It's piecewise. For what values of f is k continuous at x equals 2? So what you want to do is set the two pieces of the function equal. That's what continuous means, is that they're going to meet up, and then plug in 2. Now this one's kind of nice because they already factored it for you. These x minus 2's are going to cancel. So we're just going to have 2x plus 1 equals k. And then we're going to plug in 2 for x. That's what we want our x value to be. And so that would be 4 plus 1, so k is 5, and so that one is E. So not too bad for that one. All right, number 10. What is the area of the region in the first quadrant bounded by these graphs? In the first quadrant bounded by this graph and the line x equals 2. Right, so if we're in the first quadrant, you can draw a picture of this graph if you want. It's going to be a swoopy kind of thing because it's e to the stuff. It's going to be integral from 0 to 2 of that function. If you're in the first quadrant, you're bounded by 0, and then they gave you the line x equals 2. Now that says e to the power x over 2. I'm going to write it as 1/2 x. That's just my preference. I think that looks a little nicer than x over 2. And now we're going to do the antiderivative. So e is its own antiderivative. You just need a 2 out there to adjust. It would be a u substitution, but again, if it's real simple, just put the reciprocal out front. And then this will be such that 0 to 2. So if you plug in 2, that's going to be 1. So 2e to the first, which is just 2e. And then if you plug in 0, anything to the 0 power is 1 times 2 is 2. So 2e minus 2. And so that was choice A. So again, be scoring yourself. 9 was E, 10 was A. I want you to see how many out of the 20 you get correct. All right, number 11. Let f be the function defined by, and they give you that, which of the following statements is true? What I would do is draw a picture of this. You can just plug in some points and see what it looks like. If you plug in 2, you're going to get 0. So we're going to have a point there. If you plug in 3, you're going to get 1. And same thing if you plug in 1. 1 minus 2 would be negative 1. Absolute value that you get 1, and then square root that you get 1. So it almost looks like it's going to be linear. But if you plug in another point, and let me see what's going to work out nicely here. I think if we plug in 6, 2, 3, 4, 5, 6. If we plug in 6, we're going to get square root of 4, which would be 2. So you'd have 6, 2. And then the same thing is going to happen if you plug in negative 2, because you would have negative 4, absolute value, that is 4. Square root of 4 is 2. So you end up with something like this. It looks kind of like how I would draw a bird. But the point is, you do get that cusp there at 2. So the function is continuous. You don't have to lift your pencil when you're tracing it. Both sides come to the same point there. But it is not differentiable because of the sharp edge. So continuous, but not differentiable. So 11 is A. And if you even narrowed it down and guessed right, give yourself that point. Because, guessing right, doing an educated guess, that gives you a right answer, you get a point for that. All right, using the substitution, u equals square root of x. All right, so they start you off with that. Du would be 1 over 2 square root. Again, I think it's good to just know derivative of square root is 1 over 2 square root. And there's a 1/2 here, but we don't have a 1/2 in the problem, so we're going to adjust that with a 2. Now, I'm not going to highlight because I'm going to reuse this piece of paper, but 2 is going to go out front, du goes at the end, and what you would highlight is the square root of x that's in the denominator and the dx. These two parts are both spoken for, and all that's left is e to the square root of x, and that was u. So e to the u, which I think all the choices have e to the u in there, so it's not like you can mess that up. They all say that. And also, if you know this 2 is going to be out front, you can narrow it down as well. Last thing you have to do is adjust the boundaries. You're going to plug in 1 and 4 for x right here. So if you plug in 1, square root of 1 is 1. If you plug in 4, square root of 4 is 2. So 2 integral 1 to 2, e to the u du. So that one is C. All right, number 13. Function f is defined by that piecewise function. What is the value of the integral from 1 to 5? So we're going to have to split it at 3 because that's where the piecewise function splits. So we're going to have to do integral from 1 to 3 for the first piece of the function, and then integral 3 to 5 for the second piece of the function. So we're doing integral from 1 to 5. We just had to split it at 3 because that's where the piecewise function splits. So basically treat it as two different problems. This antiderivative is 2x. When I evaluate from 1 to 3, this would be 1/2 x squared minus x antiderivative. We want to go from 3 to 5. So this first one, upper boundary gives you 6, lower boundary gives you 2. And then this one, we're also going to do upper boundary minus lower boundary. So if you plug in 5, this would be 25 halves. I guess that'd be 12 and a half, however you want to say that, minus 5. And then if you plug in 3, you're going to have 9 halves minus 3. So let's see, 6 minus 2, this first part would be 4 plus 25 halves minus 5. I'm going to distribute this negative. And then let me collect up all the whole numbers. 4 minus 5 would be -1 plus 3 would be 2. And then this would be 16 halves, which is 8. So 2 plus 8 gives you 10. So 10 for your final answer there. And so that one is D. All right, number 14. If f of x equals this square root function, g of x equals something else, we want the derivative of f of g of x at 3. All right, so derivative of f of g, that's a composite function. This is going to be a chain rule. So you do the derivative of f, leave g alone, and then you chain on the derivative of g. So you do the derivative of the outside function, leave the guts of it alone, and then chain on the derivative of the inside function. All right, and then we want to plug in 3. So let's evaluate this first part. G of 3. If you plug 3 in for g or for x in g, this would be 9 minus 2 would be 7. So we want to do f prime of 7 for that first part, and then times g prime of 3. So we're going to need these derivatives. So first, let's do f prime. I'm going to do this off to the side here, kind of as a side problem. So this is a square root. That derivative would be 1/2 square root, all that stuff. And then you have to chain on the derivative of what's inside the square root, which would be 2x. I'm just going to go ahead and put that in the numerator. So the 2's are going to cancel, which is kind of nice. And we're plugging in 7. So that would give us 7 over, what would this be? 7 squared is 49 minus 4 would be 45. Do they leave it as square root of 45? No, they're going to split that. So I'm going to have to reduce that root in just a second. All right, times g prime of 3. All right, let's find g prime. Oh, that good. We catch a break there. G prime is actually just 3. You don't even need to plug anything in. That'll just be times 3. So 7 times 3 is 21. Square root of 45, that's going to split 9 times 5. So that would be 3 square root of 5. And then 21 divided by 3 is 7. So 7 over square root of 5, and so that one is A. All right, number 15, they give you the graph of f. Differential function, they tell you h of x is equal to the integral. So this is an accumulation function, accumulation starting at 0. Which of the following is true? Are they going to ask us all this? Okay, this is going to come from our stick-it note. First, let's look at h of, what are they asking us to plug in? 6. All right, let's do h of 6. So that is the accumulated area from 0 to 6. From 0 to 6, all that accumulated area is below the x-axis. So I don't know what exactly that's going to be, but I know that it's negative. I don't know exactly what the area of this is because it's not a geometric shape I can do the area for, but I know that that's negative. Now let's find h prime. Again, I'm going to kind of do this off to the side. H prime of x, derivative and integral cancel, and that's just going to give you f of x, which is this function. So when we do h prime of 6, That's just f of 6, which is 0. So that we can get exactly. That point on the graph is 0. And then the second derivative of h would be the first derivative of f. So the derivative at 6, derivative means slope, slope of a tangent line. If you were to draw in a line tangent to the graph here at 6, it would have a positive slope. So I don't know exactly what it is, but I know that it's positive. If I drew in a positive slope, a tangent line here, it would have a positive slope. I like questions like this because it makes you understand everything really in calculus. You have to understand an integral and a derivative, and it ties it all together. So anyway, they go in this order, negative, 0, positive. So that one is A. All right, number 16, a particle moves along the x-axis. Its position is given by, and then they give you that. A and B are constants, and they don't equal each other. For which of the following values is the particle at rest? Okay, hey guys, at rest means what has to equal 0? What are we going to set equal to 0 if the particle is at rest? Because I'll give you a hint, it's not position. What do we set equal to 0 if the particle is at rest? At rest means not moving. And good, it is going to be velocity. So we're going to set velocity equal to 0. Velocity is your derivative of position. So we're going to have to do the derivative of this, and it's another product rule. So product rule is the first function, t minus a, times derivative of the second. Derivative of t would just be 1. B is a constant, so that would just be 0. So that derivative would just be 1. You can write that if you want. Here, you know what? I'll put it in there. First times derivative of the second plus the second times derivative of the first, and the same exact thing happens. That's just going to be 1. And we're setting that equal to 0 because it says at rest. So getting rid of all the ones in there, this is t minus a plus t minus b equals 0. We're trying to solve for t. Well, t plus t is 2t. And you would add the a and the b to the other side. So if you add those over, you'll have a plus b, and then just divide by 2. So a plus b over 2. So that one is b. I hope we're still doing okay. I hope that you put your answers and you're marking them down and counting how many you got right. That's what I would be doing. Like, hey, try these and then see how many you got. Like, give yourself a score. All right, number 17, we're given a graph of f. If f, does it say f prime of x? Oh no, it says if f of x is the integral from 2 to x of g. Okay, I see what they're asking here. If f of x equals the integral from 2 to x for g of x, which of the following could be the graph of g of x? All right, we're going to do the derivative here because this is given in terms of an integral. If you do the derivative and integral are going to cancel. You just get what's inside. So f prime of x is g of x. And so what they're asking you for is the derivative. They're saying which of these graphs could be g? They're asking you for f prime. All right, so since this is linear, its derivative is going to be constant. Remember, every time you do a derivative, you go down a degree. So it's either A or B. This one is positive, this one is negative. Do you guys think it's going to be the positive one or the negative one? Is it going to be A or B based on this line? Because your derivative is going to be constant since this is linear. So it's going to be one of these. Which do you guys think? The positive one or the negative one? Good. It is going to be the positive one. And it's because slope. Derivative means slope, and this slope is positive. So A for that one. All right, let's see how I'm doing on time. I hope I can do them all. All right, number 18. Oh, I need a new piece of paper. All right, 18, they give you limit of all of that nonsense. You do not want to do this as a limit question. You want to do it as a derivative question. Do you remember back in unit 2? And I know you're already like, no. All right, well, it happened. You can go back and watch the videos. That's the cool thing about online school. Everything's recorded. Back in unit 2, I taught you that limit definition of a derivative. Remember, limit is h goes to 0, f of x plus h minus f of x all over h. I made you work that out a whole bunch of times. Anyway, that's what's going on here. We're going to figure out what's the function, which it's ln of x, And then we're going to take its derivative. So derivative of ln is 1 over x. And then we're going to plug in the value that they're asking for, which is 4. So your answer is going to be 1/4. And what they're testing you on, so that's B. What they're testing you on is, do you know this pattern? Can you pull out what's the function? Do you know how to take a derivative and then plug in the number? All right, so number 19, function f is defined by this. What points x, y on the graph of f have the property that the line tangent to the graph has a slope of 1/2? So we want to find the derivative and set it equal to 1/2 and then solve that. So this is a quotient rule. Quotient rule is the denominator times derivative of the numerator minus numerator times derivative of the denominator. I'm putting in those derivatives that are 1 just so you can see the whole pattern, over the denominator squared. And they want us to equal that to 1/2. So let me kind of clean this up a little bit. This numerator would be x plus 2 minus x, which would just be 2. And then we can cross multiply. So you'll have x plus 2 squared equals 2 times 2 is 4. And when you square root, you get plus and minus 2. So you get x plus 2 equals -2 and x plus 2 equals +2. And then solving this, you get -4 and 0. Now you would have to plug those back into the original function to get the whole point, but because this is multiple choice, you're able to just pick your answer. We want the ones that have a 0 and a -4 for their x values, and so that's C. So you can plug them back in if you want to, but it's multiple choice, so you can just pick the answer by looking at the choices. All right, number 20, let f of x be that function. Let g be the inverse. All right, this is back from unit 3 where we did these inverse derivatives. You're going to make a chart for f and f prime, a chart for g and g prime, and they want us to find g prime of 1. So 1 has to go there. This is going to be our answer. We want g prime of 1. Well, inverse means that you've not reciprocated. It means that you've reversed the input and the output. So if 1 goes here, that's the input. 1 is going to go here, that's the output for function f. And they give you that one, f of 0 equals 1. So that means this point has 0, 1, this point has 1, 0. Now we're going to need to find f prime. I'm going to just do this as like a little side problem over here, because we're going to get this value and then reciprocate it. All right, so derivative of f, this is a chain rule. You're going to bring that 3 down. It's going to drop to a 2. The guts of the problem stay the same. And then you chain on the derivative of what's inside, which is 2. So again, the 3 was the exponent that came down, it dropped to a 2. The inside stuff stays the same, and then you chain on the derivative of that stuff. Now we want to plug in 0 to that. So if you plug in 0, this whole part's just going to be 1 times 3 times 2 would be 6. And so your final answer to the whole thing is 1/6. So that one is D. So just make the chart look a whole lot easier to sort out what you're looking for. All right, 21, let me zoom out. I zoomed way in so we could read the questions, but then that gives me even less space to show you anything. All right, the line y equals 5 is a horizontal asymptote. That means your limit as you're going to infinity of the function has to equal 5. And when you go to infinity, you're comparing the exponents. So if your numerator power is smaller than the denominator, it's automatically 0. When they're equal, you use the coefficients, the leading coefficients. And if your numerator is smaller than if your numerator is bigger than the denominator, then you have a slant asymptote. It's going to either go up or down, positive or negative infinity. So I'm going to tell you which one's the answer. You can look through the wrong choices if you want. It is going to be E. If you look at your powers, this one's squared and this one's squared. That's a tie. So you would use their coefficients, 20 over 4, which gives you 5. So again, if you have a horizontal asymptote, you're looking out to the edges. So out to infinity, and we wanted it to level off at 5. All right, 22. Let f be the function defined by this. What is the absolute minimum? That's a candidate's test. All right, so we're going to first get the critical points. We need the derivative. This is a quotient rule. It is denominator, derivative of the numerator, minus numerator, derivative of the denominator, over denominator squared. We're going to set this equal to 0, and then we're going to make a chart and see which one's the biggest and which one's the smallest. So here these x's cancel. In the numerator, you would have 1 minus ln of x equals 0. So I'm going to subtract over the 1. Negatives cancel. And then you would exponentiate both sides. It's e to the power of, and you get x equals e. So e is one of your critical points. The other one's going to be 0. You can also have a 0 denominator for a critical point. It's where this equals 0 or is undefined. And if you set x squared equal to 0, you get 0. Now you're going to plug those back into the original function. ln of e would be 1 and then over e. And if you try to plug in 0, you can't ln 0, so that doesn't even give you a result. So this has to be your maximum, 1 over e. Remember, this is what your ln graph looks like. You can't ln 0 because there's an asymptote there, and you also can't ln any negative numbers either. So 1 over e for that one, and that is b. It's really tricky because e is also a choice, isn't it? Isn't e? Oh no, e isn't a choice. Okay, cool. So they didn't make that. Because if they made this a choice, that's really tricky because sometimes people pick that one instead. All right, 23. Oh, I'm remembering this one. This was actually a homework problem that I picked for you. So we've done this already. P of t is the population, is the size of a population, which describes linear growth. It is going to be A. If you have linear growth, that means that the growth is constant. So you have to pick the one that doesn't have a variable in it. So no work for that one. So that's nice because I'm running out of time. I'm going to get them all done. Let's see. All right, let g be the function given by that. K is a constant. For what value of k does g have a critical point at 2/3? So you want to do derivative at 2/3 equals 0. This is actually also a homework problem. I remember doing this one as well. If you have a critical point, its derivative equals 0. They just want it to be at 2/3. All right, so let's find g prime. It's going to be a product rule. First times derivative of the second, which is e to the kx times k, and there's a chain rule there, plus second times derivative of the first. So it's your product rule, and there was also a chain rule in there. I'm going to factor out, let's see, what can we factor out? We can take out an x and an e to the kx. That's our greatest common factor. If you factor that out, you are left with kx plus 2. Now, this is never going to equal 0. Well, I guess that's 0, but exponential is a swoop that has an asymptote there. So this is the one we want to look at. And we wanted to plug in 2/3 for x. So we would have 2/3 k plus 2 equals 0. And that's what we need to solve. So subtract over the 2. And then multiply by 3 over 2, and you will get -3. So that one is A. All right, I may go over by a minute, but I am going to finish these last 4 problems just so that we have them all done here on the video. Which of the following is the solution to this differential equation, initial condition pi 1? I think we did this one as a homework problem too. So you're going to multiply over the dx and then do the antiderivative. And the nice thing about this one is it's just going to be y equals. This antiderivative would be -2 cosine of x plus c. And the reason it's negative is because derivative of cosine would be negative sign. You just need the negative to cancel that out. We're going to plug in pi for x and 1 for y. Cosine of pi would be -1 times -2 would just be 2. And so c is -1. And so if you recopy this line and put the -1 back in there, that's going to be your answer. So -2 cosine of x minus 1. So that one is E. All All right, 26. Let g be a function with a first derivative given by that. Oh, and there's an integral in there, super fun. Which of the following must be true on the integral? And then they're asking about increasing, decreasing, and concavity. So this is what we're looking at. If your first derivative is positive, your function's increasing, negative, your function's decreasing, and then second derivative tells you about concavity. All right, so let's see what's going on with our first derivative here. This is the first derivative. Now, e to the stuff, and I realize there's a negative in there. That just means it's been reflected over the y-axis. I don't know exactly what that graph is going to look like, but I know it's above sea level. If you graph this e to the whatever, it's going to be above the x-axis. I don't know exactly what it's going to look like without, spending more time on it and plugging in some points, but it's going to be positive because it's going to be a swoopy kind of thing with an asymptote here. So if you're accumulating area under the graph, it's going to be above sea level. It's going to be positive. So our first derivative is positive. That means that the function is increasing. So you can narrow it down to a or b, right off the bat. All right, and then when we go to get the second derivative, derivative and integral cancel. That's just going to give you e to the negative x squared. And again, that graph is above the x-axis. It's above sea level. So our second derivative is also positive, which means concave up. It was kind of silly because it was an exponential graph. It's going to be above the x-axis. So increasing and concave up. All right, 27. If, all this is true, what is the value of the second derivative at the point 3, 0? This one's going to be a little bit of work. First, I'm going to divide this over. And then we're going to do the second derivative. So the derivative of this. So that's going to be a quotient rule. It's going to be the denominator times derivative of the numerator, which would be 2 minus dy dx, minus the numerator times derivative of the denominator, which would be 1 plus 2 dy dx over denominator squared. And I realize I'm at the end of class time. If you have to go, that's fine, but I'm going to finish these last 2 questions so that I can record this so that it's all done for you. All right, and then they wanted us to plug in the point, 3, 0. So x is going to be 3, y is going to be 0. I just need to know what dy dx is going to be at 3, 0. So at 3, 0, this numerator would be 6, and this denominator would be 3. So that would be 2. So we're going to plug in x is 3, y is 0, and dy dx is 2. That's what we're plugging in for this horrible mess here. All right, so this first part's going to be 3. This would be 2 minus 2, which is 0. So that part's going to be gone. This would be 2 times 3, which is 6. What are we plugging in for this? 2. So that'd be 4 plus 1 is 5. And then over 3 squared, which is 9. So again, this first part's gone. This would be negative 39ths. They're both going to divide by 3. So negative 10 thirds for that. There's a lot of algebra in that. So that one was A. All right, and then last one, 28. For positive times, the position of a particle moving along the x-axis is given by, and they give you sine of t minus cosine of t. Again, that's position. What is the acceleration of the particle where its velocity first equals 0? All right, so we're going to need velocity and we're going to need acceleration. So that's the first derivative and the second derivative. Sine and cosine just sort of bounce back and forth from each other. So this is going to look like we're writing the same thing over and over. Derivative of sine is cosine. Derivative of cosine is negative sine. So those negatives are going to cancel. And if you do the derivative of that, again, derivative of cosine is negative sine. Derivative of sine is cosine. So we want to plug something into acceleration. It says, what is the acceleration when the velocity first equals 0? So what you're going to do is set the velocity equal to 0, solve that, and whatever time you get is going to get plugged in here. Now, it doesn't matter which one of these you subtract over when you set this equal to 0. You're looking for a place where sine and cosine are equal, but opposite signs. One of them's negative. So that's going to happen in the second quadrant. You get sine is square root of 2 over 2. Cosine is negative square root of 2 over 2. This would be 3 pi over 4. And then it happens again in the fourth quadrant. But we want, it said when it first equals 0. So we want the 3 pi over 4. So negative sine of 3 pi over 4 is this, square root of 2 over 2, and then sine's the y value. Cosine of 3 pi over 4 is this negative square root of 2 over 2. So they're both negative. And so if you have negative of something and negative of something else, you now have negative 2 of them. And there are 2's everywhere in the problem. But these cancel and you just get negative square root of 2. Again, if you've minused one thing and then you minus another, you've now minused 2 of them, but then the 2's cancel. So negative square root of 2, and so that one is A. Phew. All right, I only went 5 minutes over. That's not too bad.